Greetings, math fans. Alright, so we're going to do a couple more different special cases. That's actually a pretty quick lesson. So the first thing I want to talk about is double angle. Okay, so this is, you've already talked about double angle. We know what it is, right? So let's do cosine first. So it's cosine. Now usually it's cosine of 2 theta, right? But we're going to do cosine of 2 sine, inverse sine of negative 3/4. So because this is theta, right? That represents an angle. So you need to recognize this as cosine of a double angle, and the way you do that, right, is cosine of 2 of something. Okay, and it's 2 theta. So the key here, math fans, is you need to draw a picture. All right, and this is just like we did in previous lesson, where you're actually drawing a picture, right? You have the cosine and on the outside and the arc, or the inverse on the inside. Remember, it's on the inside you draw a picture. So, of course, this is inverse sine, which dictates it's going to be here where it's negative. Sine is y over r, so negative 3, and this is 4, and so this is going to be 16 minus 9, so this is going to be root 7. So what we're going to pull off of this picture is we're going to pull, well, let's talk about actually what is cosine of 2 theta. Do you guys agree it can be one of 3 things? It can be cosine squared of theta minus sine squared of theta. It can be 2 cosine squared of theta minus 1, or it can be 1 minus 2 sine squared of theta. So let's think logically. What does it make sense to do here? Okay, any one of those are correct. But here's the deal. If you think about it, aren't we given sine? So why not use this one? Because I'll tell you, if you made a mistake figuring out that root 7, let's say you said 16 plus 9, okay, and you set it like a 3, 4, 5 triangle, and then you use one of the other two with cosine, you get it wrong. So why not just use the one that is it's using the given information? You'll kind of be all set. So this is the one that I'm going to use. And basically, it's 1 minus 2 sine squared of theta. So sine of theta, well, we already know that. It's negative 3/4. You can even pull off the triangle again if you wanted to. So our answer to this one, go over here, it's going to be 1 minus 2 times negative 3/4 squared, which is 1 minus 2 times 9/16, or 1 minus 18/16, right? Or 1 minus, so it's 16/16 minus 18/16 is negative 2 over 16th, or negative 1/8. That's the answer to that problem. Okay? So again, it's a double angle for cosine. Let's do one for sine. Sine of 2 inverse cotangent of negative 1/2. Once again, math fans, you totally can recognize this as a double angle for sine because it says sine of 2 blah. And again, that blah right here, that's your angle theta. Okay? So let's write it out here. Sine of 2 theta equals 2 sine theta cosine theta. So make a picture. Okay? Because again, the arc is on the inside, you're taking a picture, or you're drawing a picture. It's cotangent, so do you guys agree we're over in this quadrant here? And it's the xy, so it's negative 1 and 2. Okay, and then this is going to, with the Pythagorean theorem, it's going to be root 5. Okay, so we'll just need sine of theta. So it's going to be 2, and sine of theta, looking at this, is y over r, so 2 over root 5. And x over r, negative 1 over root 5. Now, some of you are probably looking at this going, Mr. Curvis, you didn't rationalize the denominator. Well, think logically again. You guys are smart kids, okay? Look at this, and why didn't I rationalize the denominator? Because I have the same denominator here, and it's going to come out to be a nice, if I multiply root 5 times root 5, it's just 5. So my answer for this one is negative 4/5. Okay? So that's pretty easy. That is double angle. So let's do sum and difference now. It's going to be pretty easy too. Sum and difference. Okay, so let's start out with sine of arc tangent of negative 7 over 24 minus arc cotangent of negative 4/3. Okay, well, obviously it's sine sum or difference. In this case, is difference, right? A minus B. So I would recommend, if you first of all, you got to draw a picture for each one of these. So let's just actually do that quickly. Okay. So the first one, it's arctangent, and we know arctangent, when it's negative, it's in this quadrant here, and this is going to be it's negative 7 over 24, so it's the ox, negative 7, 24, it's a 7, 24, and this is 25 for R. And then for B, our cotangents, we're going to draw it in this quadrant, and it's going to be the xy, so negative 4/3, and this is a 3, 4, 5 triangle. Okay, so what we need to pull off of here is we need to pull off, because remember, let's just write it out here, and I think it's a good idea to write out sine of A minus B is equal to sine of A cosine of B, same sign, cosine A sine of B. Okay, so basically what I needed for each of these triangles, I needed to come up with sine of A, sine of B, cosine of A, cosine B. Okay, so let's do that. For the first one, sine of A is it's negative 7 over 25. Cosine of A is 24 over 25. Sine of B is equal to 3/5, and cosine of B is equal to negative 4/5. Okay, and then we plug those values right into here. Okay, again, I don't want to see you guys saying, oh, sine of 3/5 or sine of negative 7 over 20. I mean, sine of A is negative 7 over 25. So we have negative 7 over 25 times cosine of B, which is negative 4/5, minus cosine of A, which is 24/25, sine of B, 3/5. Okay, so I multiply that out, I get 28 over 125, and that's 3 times 24 is minus 72 over 125. So 28 minus 72 is negative 44 over 125. That's my answer. Okay, that's pretty easy, right? Not that bad. Okay, let's just do one cosine, just to refresh your brains with cosine. Cosine of the arc sine of negative 12 over 13 plus inverse cosine of negative 3/5. Okay, so again, you recognize this, of course, as cosine of A plus B. And just like, let's recall it, right? That's cosine of A, cosine of B, opposite sign, sine A, sine B. Okay, so we're going to make a nice picture for each one of these. Arc sine, so we're going to be in this quadrant here, and it's going to be x or y over r, so negative 12, 13, and this is 5, and cosine is negative here, so it's it's x over r, so negative 3, 5, and this is 4. Okay, we'll call this one A, and this one is our B. So sine of A is equal to negative 12/13. Cosine of A equals 5 over 13. And sine of B is 4/5, and cosine of B, which actually is up there already, negative 3/5. Okay, so then we plug that in. Cosine A, 5/13. Cosine B, negative 3/5. Minus sine A, negative 12/13. And sine of B, 4/5. Okay, so we get negative 15 over 65, double negative, so it's plus 48 over 65. Okay, and that gives us 33 over 65. Okay, that's it. So that's cosine sum and difference. In this case, it's sum. Okay, so that's pretty easy, and that's kind of today's lesson. So it's kind of mellow, but just make sure you recognize, you know, if it's a double angle or if it's a sum and difference. Really pretty easy. Draw a picture because again, the arc is or the inverse is on the inside, so you have to draw a picture to figure out where the different angles are, different ratios. Okay, that's it, my fans. Have an outstanding day. Adios. Goodbye.